In August 1978, a group of preservationists arrived at a farm near Milo, Alberta, to remove the remains of a de Havilland Mosquito. The aircraft had spent roughly 3 decades outdoors. Its engines were gone, its landing gear had disappeared, other parts had been removed over the years. What remained still had the outline of one of the fastest aircraft of the Second World War, but the structure beneath that outline had been steadily weakened by weather. The men prepared the Mosquito for transport. Then the forward fuselage disintegrated. The remaining body broke into 2 large sections as it was being placed on a trailer. The aircraft had survived military service without being damaged in combat. It had survived the post-war disposal system, but during the attempt to rescue it from a Canadian farm, it could no longer support its own weight. Its serial number was KA114. 34 years later, that same identity would be attached to a Mosquito accelerating down a runway in New Zealand. 2 Merlin engines would pull it into the air, making it the first aircraft of its kind to fly in 16 years. The distance between those 2 moments was not covered by an ordinary restoration. To return KA114 to the sky, a team would have to recover something larger than the aircraft itself. They would have to recover the lost method of building a Mosquito. KA114 had been completed in Canada during the final months of the Second World War. It was a fighter-bomber version of the de Havilland design, built at Downsview, Ontario, and accepted by the Royal Canadian Air Force in February 1945. By then, the Mosquito had already established its reputation. Its combination of speed, range, and versatility allowed different versions to serve as bombers, reconnaissance aircraft, night fighters, and fighter bombers. Much of that performance came from its unusual construction. Instead of relying on a conventional all-metal fuselage, the Mosquito used a lightweight, bonded wooden shell. That made the aircraft strong and efficient in flight. It also made the condition of the wood and adhesive essential to the strength of the entire structure. KA114 reached service too late to take part in the campaigns that had made the type famous. It spent a short period associated with No. 7 Operational Training Unit at Debert, Nova Scotia, then passed through storage and reserve organizations. There was no combat damage in its history, no emergency landing, no missing crew, no final wartime mission. The war ended and KA114 became surplus. In 1948, the Royal Canadian Air Force released it through the post-war disposal system. A farmer near Milo acquired the aircraft, and the Mosquito began a second existence far removed from military aviation. For years, it remained outside. The engines and undercarriage were removed. Components vanished. Sun, rain, snow, and changing temperatures reached a structure that had never been intended to survive decades of exposure without maintenance. An aluminum aircraft can remain recognizable even as corrosion spreads through it. A bonded wooden shell can also retain its external form while the strength inside is disappearing. The fuselage of a Mosquito depended on layers working together. Thin plywood skins enclosed a lightweight core, with wooden frames and reinforcement carrying loads through the shell. When moisture damaged the wood or weakened the bonds between those layers, the aircraft could still look complete from a distance, but appearance no longer guaranteed strength. By the late 1970s, KA114 had become a rare survivor and an extremely fragile one. Ed Zaleski acquired it for the Canadian Museum of Flight and Transportation. The intention was preservation, yet the collapse during removal showed how far deterioration had progressed. The museum saved what remained and placed the surviving sections under cover. Some metal components and parts of the wing were in better condition than the shattered fuselage, but there was no simple path from those remains to an airworthy aircraft. A conventional restoration normally begins by inspecting an existing structure, repairing damage, and replacing parts that cannot be saved. KA114 presented a different problem. Its primary wooden structure was not merely damaged in a few isolated places. Large sections had lost the strength required for flight. A static reconstruction might have been possible. A museum could have created the shape of a Mosquito and supported it internally. But returning KA114 to the air would require a structure capable of carrying the engines, landing gear, fuel, crew, and aerodynamic loads of flight. That structure could not be created by hiding deterioration beneath a restored surface. For more than 2 decades, KA114 remained a collection of preserved components and unresolved questions. The most important of those questions was not how to repair the wreck, it was how to build a Mosquito again. In New Zealand, Glyn Powell had already begun searching for an answer. Powell's interest in the Mosquito developed into a long investigation of the way de Havilland had manufactured the aircraft. He collected drawings, examined surviving examples, and studied the coordinates that defined the fuselage shape. The original Mosquito factories had formed each fuselage on large moulds. Those moulds supported the layers of wood while the 2 halves of the shell were built. After curing, the halves were removed, fitted around the internal structure, and joined together. The wartime production lines were gone. The original molds were no longer available. Drawings could show Powell the shape of the finished aircraft, but they could not simply recreate the factory equipment needed to produce it. Before he could build a fuselage, he had to reconstruct the tools that gave the fuselage its form. That reversed the usual logic of aircraft restoration. The first major object Powell needed to create was not part of an airplane. It was a mold, almost 37 feet long. He calculated the required shape from the surviving technical information and from measurements taken from existing Mosquitoes. 2 full-length molds were required, 1 for each half of the fuselage. Once completed, they made it possible to reproduce the basic de Havilland construction method. A thin layer of birch plywood formed the inside of the shell. Balsa and wooden reinforcement created the core. Another layer of plywood formed the exterior. When each half had been completed and removed from its mold, the 2 shells could be joined around the main bulkheads and internal structure. Modern adhesive would replace the original wartime glue, but the fundamental approach remained recognizable to the people who had built Mosquitoes decades earlier. Powell had not yet restored KA114. He had done something that made its restoration possible. He had rebuilt the method. In 2004, American collector Jerry Yagan purchased the surviving components of KA114 for his military aviation museum. The remains were shipped to New Zealand, where the project became a partnership between Powell's Mosquito aircraft restorations and Avspecs, led by Warren Denholm. The objective was clear. KA114 would not become a static exhibit. It would be rebuilt as an aircraft capable of certified flight. That objective forced the team to make careful distinctions between preservation and safety. Some original KA114 components could be restored and used again. Other period Mosquito parts could be found, inspected, and returned to service. But the main wooden structures would have to be new. This was not an attempt to disguise the condition of the original aircraft. The restoration record openly showed what had survived, what had been replaced, and what had been recreated. The serial identity, documentation, and recoverable parts continued as KA114. The fuselage, wing, and tail structures required for flight would be manufactured again. Powell's operation began producing the major wooden assemblies. The fuselage shells were formed over the recreated molds. Internal reinforcement and bulkheads were fitted. The 2 halves were joined into a complete body. A new wing was also built. On the Mosquito, the wing was not simply 2 separate panels attached to either side of the fuselage. It was a continuous structure running from one wingtip to the other. It carried the weight of the fuselage, the 2 engines, the landing gear, fuel, and the loads created in flight. The surviving wing could contribute components and information, but an airworthy KA114 required a trustworthy central structure. New wooden spars and skins were built in a dedicated jig, using materials that could be inspected and certified. The choice was unavoidable. Original wood that could no longer carry its designed load had historical value, but it could not be allowed to determine the safety of the finished aircraft. The major wooden structures took nearly 3 years to complete. Then the project moved deeper into final assembly. At Avspecs, the clean shape of the Mosquito began to fill with systems. Usable controls and cockpit components were restored. KA114's original throttle quadrant and control column could return to the aircraft. Hydraulic and electrical systems were installed. New piping was manufactured, rather than relying on old lines that might fail under pressure. Other parts had to be found or created because no supplier still produced them. Radiators were reconstructed, cowlings and undercarriage doors were completed. A full set of propeller blades was assembled using surviving material and carefully adapted components. 2 Rolls-Royce Merlin 25 engines were prepared for the aircraft. Every choice required the same basic judgment. Could an original part be inspected and trusted? Could a period component from another Mosquito be restored? Or did the function demand a newly manufactured replacement? The completed aircraft would not be entirely old or entirely new. It would be the result of thousands of decisions about where historical material could continue working and where safety required reconstruction. The project lasted 8 years. By September 2012, KA114 once again looked complete. But a complete appearance was not proof that it was ready to fly. The next stage began with the engines. On the 19th of September, the first Merlin was started. The run revealed 2 small fuel leaks caused by loose bolts. They were corrected. The following day, the team carried out weight and balance checks. A rebuilt aircraft must not only meet an expected total weight, that weight must also be distributed within limits that allow the pilot to control it safely. On the 21st, the second engine was run. 2 days later, both Merlins operated together, and KA114 moved under its own power during its first taxi tests. Each successful step changed the status of the project. The remains that had arrived from Canada had become a structure. The structure had become a complete aircraft. Now the aircraft was beginning to behave like a machine designed for flight. Civil aviation inspectors examined it over 2 days. The team completed the final details and corrected problems as they appeared. There was no need to invent drama. Any serious fault in the fuel system, hydraulics, controls, engines, or structure could have delayed the first flight. Progress depended on one test being completed before the next began. After the first Merlin ran, Glyn Powell offered a brief assessment of how far the project had come. People have almost stopped laughing now. On the morning of the 27th of September, KA114 stood at Ardmore with both engines ready. Dave Phillips was in the pilot's seat. Warren Denholm occupied the other position. Nearby, Rob Silich prepared a T-28 Trojan that would serve as the chase aircraft. The purpose of the flight was not to perform for a crowd. It was to test the Mosquito. The chase pilot would watch the landing gear doors and look for visible leaks or anything unusual. Phillips would evaluate the controls, engines, flaps, and landing gear through different stages of the flight. The Merlin started. For years, the central challenge had been hidden inside pieces of wood, old drawings, and unfinished assemblies. Now the result stood on its landing gear, vibrating under the power of 2 engines. KA114 began to taxi. It turned onto the runway. The engines rose to take off power, and the aircraft accelerated. In Alberta, the Mosquito had broken while being placed on a trailer. At Ardmore, it lifted away from the ground. For the first time, Powell's recreated molds, the newly bonded fuselage shells, and the new full-width wing were carrying the loads of flight. The T-28 moved alongside to inspect the aircraft. Phillips tested it at different speeds. The landing gear was raised and lowered. The flaps were operated. The crew watched the engines and systems as the aircraft continued over New Zealand. The first stage of the flight lasted approximately 45 minutes. KA114 landed at Auckland International. The main reported issue involved the airspeed indication, not the basic behavior of the new structure. Keith Skilling later carried out another test flight before the Mosquito returned to Ardmore. The reconstruction had passed its most visible test. KA114 was flying. It was the first Mosquito to do so since July 1996, when the last previously airworthy example had been destroyed in a fatal accident in Britain. For 16 years, the sound of a Mosquito in flight had been absent. Now it had returned, through an aircraft that had once been considered little more than a deteriorated collection of parts. 2 days after the first flight, KA114 appeared before the public at the Mosquito Launch Spectacular. The aircraft carried the code letters EG-Y, associated with number 487 New Zealand Squadron. Those were not KA114's original military markings. The Canadian-built aircraft had never served with that squadron and had never flown combat operations in Europe. The markings acknowledged the country and the people who had brought it back to flight. They connected a Canadian airframe identity with New Zealand's wartime Mosquito history and with the modern reconstruction carried out at Ardmore. After the New Zealand test program and public appearances, KA114 was dismantled for transport to the United States. Moving the aircraft was another carefully controlled operation. The Mosquito's large, continuous wing, engines, and systems had to be separated, shipped, and correctly assembled again. Avspecs personnel helped reassemble it in Virginia. In May 2013, KA114 flew in the United States and joined the collection of the Military Aviation Museum at Virginia Beach. Yet the most important result of the project was not limited to a single aircraft or museum. Before KA114, Glyn Powell had spent years trying to determine whether the manufacturing process behind the Mosquito could be recovered. The completion and flight of the aircraft provided the answer. The molds worked. The wooden construction method could be reproduced. The skills developed during the project did not disappear when KA114 left New Zealand. They contributed to later restorations and helped additional Mosquitoes return to the air. That was the deeper recovery. The original primary structure of KA114 could not be preserved intact and returned to flight. Too much had been lost during its years outdoors. Repairing the surviving shell would not have created a safe aircraft. Instead, the project preserved what could be trusted, recreated what had disappeared, and rebuilt the industrial knowledge required to join the two. KA114 had survived the war because it arrived too late to fight. It nearly vanished because peace left it unwanted and exposed. Its return began only when the team stopped asking how to repair the wreck in front of them and began asking how de Havilland had built a Mosquito in the first place. In 1978, the aircraft broke beneath its own weight. In 2012, it carried itself into the sky. The wood was new, the method had been recovered, and the name on the aircraft was still KA114.